So there are a couple terms I want to go over real quick with osmosis. As mentioned in the last slide, you can see, remember, it starts off everything's equal, and then all of a sudden, oh my gosh, the left-hand side is loaded with water, and the right-hand side just lost a ton of water. There are terms for this that are very important, and we're going to use those right now in terms of cells. So if we have the same amount of osmotic pressure on each side of the cell, meaning equal amounts of water comes into the cell as water leaves the cell, it stays the same, right? That's called isotonic, right? So if you are isotonic, that means it is iso, it is the same. So nothing's going to change. So in this red blood cell, it stays the same. It's normal. But if I start to change the concentrations of salt or sugar or water, that will impact the movement of water in and out of the cell. For example, if I have a hypertonic solution, all right, meaning that I bump up the salt concentration a lot, right? What's going to happen is there's going to be a lot of salt in the environment. So, in the blood, in the liquid of the blood. So now what's going to happen is all of the water inside of that cell is going to leave the cell and go into the environment. Why? Because as you see here, a red blood cell is about 0.85% sodium chloride, right? But if you bump it up to 1.5%, now all that water is going to leave the cell. If you do the opposite and lower the osmotic pressure, what's going to happen is now the water is instead going to rush into the cell because the inside of the cell is more salty than the outside. So if I lower it to 0.25, that's way less. So now all the water is going to rush inside of the cell and they're going to get really large and filled with water until they burst. So that's called hypotonic. All right, so those are the three terms having to do with osmotic pressure. And again, we will do this in lab as well.